on.
Bonjour à tous. Good morning, everyone. My name is Nicolas Delenard, Insights Team Sales for NoviPro. It's a pleasure for me to be the host for today's presentation from Christoph Schwartz from Illumio about seeing your risk, take simple steps to stop ransomware. At the end of the presentation, we will have a short period of time for your question, and we have a hard stop at noon. You can always ask a question to the booth of Illumio. You will find it under the partner page, sorry. And now a little bit about Christer. Christer is the principal technical marketing engineer for Illumio. He has spent many years in the networking industry. He worked for Cisco, Netflix, Palo Alto, and now he currently works for Illumio, focusing on architecting workload security in data center and hybrid cloud network fabrics. Now the floor is yours, Christer.
Thank you for that. I'm going to spend a little bit of time discussing a topic that's on everyone's mind today, and that's ransomware. Ransomware is in the news everywhere, and it's very frightening, and many people are concerned about how to protect themselves against it, but are not quite clear on how it works and how to fix the problem without breaking production. So I'm going to talk about some overall models or things to keep in mind about how to protect yourself quickly and at scale. You should be able to protect yourself against ransomware, whether you have 10 workloads or 100 workloads or 100,000 workloads. You should be able to avoid this risk to your business model without breaking your business model as you go on towards your goal of zero trust and micro-segmentation. These are all goals everybody wants to reach, but it's often scary and complicated, and we want to solve this problem first. How do we deal with ransomware today as we go towards our zero trust journey tomorrow? Ransomware is not new. Ransomware has been around for quite some time. It was first born in the late 1980s, and it actually was delivered via floppy disk. You would get an infected floppy disk, you would send money to Central America, and then somebody would send you a new floppy disk to fix the first one. This idea has been rediscovered by modern hackers, by modern criminals, to great effect. They can very easily access this tool to do a lot of significant damage today, using the fact that some aspects of computing have not changed since the 1980s. And this is what's putting us at risk to ransomware. And we want to somehow be able to protect ourselves with that, regardless of whether our business model is running on bare metal computers, whether on virtual machines, whether on containers. We want to stop this vector, this problem, regardless of how we are running our business and doing it again at scale. This is a perfect criminal business model. You know, if you want to cause a significant amount of damage today, you just go to the dark web, and there are ransomware as a service portals out there, complete with their own help desk, where you download this tool, you simply choose who to attack, and demand ransom in Bitcoin. And often, it's cheaper for these big companies to pay the ransom than to fix the problem. And if you're a modern criminal, keyboards are much lower risk than guns. And this works very well. We've all heard this on the news. But why is this such a problem? How is it that we're all at risk from this very old problem? This has to do with the fact that almost all OSs today listen to certain ports by default that you may or may not need. So whether your workloads are bare metal or VMs or containers, they're often listening to things like remote desktop protocol ports or SMB ports, which is an old way of sharing files or printing. All OSs are listening on these ports, even if they don't need to. Now, this is RDP, for example, is generally used by some kind of help desk to take control of your system and fix a problem. But that's not going to be something that workloads need to speak to other workloads. And all it takes is for one of these hosts to be infected by ransomware and traverse these ports and very quickly infect them. And it turns out that as of late 2021, something like 70% of ransomware malware is propagating over these ports that have been turned on OSs for a long time. And all it takes is one host to be infected, and it very quickly can spoof these connections and hop to other ports. And before you knew it, your entire environment is infected. And the first you learn of it is when you get your warning for ransom. So how do we stop this? How do we allow for the fact that we sometimes will need RDP in certain instances, But how do we stop workloads from talking to each other without having to go to every single one? Most workloads have some kind of built-in firewall. Linux has IP tables, Windows has Windows filtering platform. I can go to each one of those and turn these ports off, but this is a scaling problem. If I have a very large hybrid cloud environment, this is not realistic. So we need some kind of centralized way of turning these ports on and off and blocking the way 70% of these tools are causing damage to my business. The question is, where do we put this protection? There's broadly 4 layers in a compute architecture to put this environment, this kind of protection in the environment. And if we start from the bottom of this layer and look up, it's sort of a historical approach to this. So all data centers, all clouds are networks. And in the network, you have switches, you have routers, you have firewalls, and various appliances. And these are generally networking devices that have been around for decades. And they will create segments of a sort to solve networking problems. So you'll see VLANs in this part of the fabric. You'll see IP subnet. You might see private VLANs. But this is a fabric this is a model in which segmentation and creating isolated segments is done for networking reasons. These are meant to solve things like DDoS and ARP spoofing. But really, ransomware, to protect ransomware down at the network layer by putting a firewall or some kind of network security appliance in place, is just simply not going to scale in the modern hybrid cloud world. SDN is a solution that's been introduced several years ago, which really automates a lot of the functions at the lower layer. We're centralizing networking functions, and we're creating an overlay across this, and we're using things like VXLAN instead of VLANs. But this is still a network-centric view of the world. We're going to use those things to create segments at the network and try to access applications and create segments for them. But we're not going to be doing, say, tens of thousands of segments at this layer. These are still tools for networking priorities. We can move this networking edge up into the hypervisor, and there are several vendors there who will do that. And they will often take what's down at the bottom layer and virtualize them. So you'll find virtual routers, virtual firewalls, virtual load balancers, and certain segmentation down at that layer. But still, these are still network-centric things. If we're talking about things like ransomware, ransomware is a problem that's directly at the workload. If we're going to put a solution to protect a workload, let's put the solution there at the workload, not to replace the lower layers. These lower layers still need security for networking reasons. But ransomware is very much a workload-centric problem, and we want to put a solution there, directly at the workload, but without breaking the workload. How do we solve the problem there, but without adding something heavy and something that's going to get in the way of my production? Keep in mind that networking security solutions have networking priorities. So when you put security devices in the network anywhere, whether it's cloud or data center, the concerns there are largely around traffic engineering and preventing DDoS and authentication and things like this. And to create segments for this, if you want to segment parts of my network, we're probably going to be creating segments in terms of the hundreds, maybe a few thousands. But if you have an environment where you have, for example, microservices, containers, Kubernetes can create a huge number of things that can talk to each other and potentially segment. And you're going to need to have significantly larger numbers of segments in a workload environment, because workload security priorities are very different than network. So when we talk about workload security, we're talking about ransomware, we're talking about lateral movement, we're talking about command and control behavior, we're talking about IoT. So therefore, when we talk about securing the workload, we need to talk about solutions that are sort of agnostic to the network. So we don't want to replace what's in the network, but we want to put something in place that will solve a problem that the network is really not designed to address. So with that in mind, we need to look at sort of the broader picture. All of your workloads can be hosted either in some kind of on-premise data center or in some kind of public cloud environment. And if we visualize those workloads as either bare metal or VMs or containers, regardless of location, we can use an approach where we put an agent on each one of these devices. Now, this is an agent that sits in the management plane. If we put an agent in the data plane, we're introducing something in line and we're creating some risks involved. Illumio's approach is, let's not put a new shiny tool into your environment. Let's use what you already have. You already have IP tables in Linux. You already have Windows Firewall. filtering platform. Your bare metal servers have theirs. So let's put an agent there and manage that. So essentially, these agents are sitting in the background doing netstat commands, collecting telemetry, and sending that telemetry back to a centralized engine. And this is where we want to be able to see exactly what's going on, which process is using which port, who owns what IP address, and have this be independent of networking constructs, okay? And we want to be able to label this. So we want to be able to tag these workloads with some kind of metadata. So instead of identifying workloads in the traditional way that a firewall would, where this IP can speak to that IP, I want to be able to take, let's say, all my SQL servers around the world, across all my clouds. If you're a SQL server, I'm going to name you SQL. If you're a web server, I'm going to name you web. And I want to be able to visualize things that way. I want to know what are all my SQL servers doing to all my web servers before I have to drop down to the network layer. I want to be able to visualize this that way. So at the very top level, I want to get some kind of application dependency picture from the application layer. So users perceive workloads in ways that have nothing to do with the network. So if they say that my SQL servers break, they rarely say this IP can't talk to that port. They just say my SQL servers break. So I want to be able to use that to visualize what's going on. I then want to be able to write policy that way. So I want to say my SQL servers can do this to my web servers in London, but not in Cape Town. And I want to send that information back down to the workloads and control this at scale. And these workloads should be managed if there are 10 workloads, 1,000 workloads, or 100,000 workloads. We want some centralized way of addressing these, and with the end goal of creating every workload as a segment. So if we want to define zero trust from this level, it means that however many segments you have, that's how many workloads will be protected. So if I have 10 workloads, in a traditional environment, I could get 10 VLANs because the network will now be creating those segments. But if I have 10,000 segments, the network will not give me 10,000 VLANs. So I want to be able to have every single workload be its own segment, independent of whatever the network is offering. Because I maybe want to move a workload from the data center to a cloud and not have to rely on the underlying fabric every time I move my workload. And the result is I want this. This is the highest level view of my workloads. So each of these bubbles are either geographic locations, or they could be abstracted workload centric. So in the upper left, I could have all my ordering systems, and in the bottom, all my HRM systems and point of sales. And I just want to see who's talking to who. And from this perspective, I have a very clean picture of where my traffic is. I can very quickly see if there's any kind of compliance violation here, if one environment should not be talking to the other. Green means that we are enforcing policy. We're allowing traffic to go from these workloads to the others. Red means we're blocking it. We see traffic trying to use it, but it is being blocked. So this allows me to view everything from the top level. And this is where I want to start addressing ransomware, because this is where ransomware is a problem. If any one of these workloads is infected with ransomware and it uses RDP ports, it's going to be if I'm not enforcing correctly, I can very quickly have a problem with ransomware spreading everywhere before I know it. Now, in order to get to this, often full enforcement is a goal we want to get to. We want to be able to fully enforce all of these workloads where we're employing an allow list model. Only those ports that I want are allowed and everything else is blocked. But this assumes you understand how your network works. Often people don't quite get to that level because they're still collecting information before they can define that allow list model. Ransomware is an immediate problem. I don't want to have to wait for full enforcement before I can fix ransomware. So how can I fix ransomware today while I still sort of have a visibility solution where I can see what's going on before I start locking traffic down? The traditional networking model is this. If I have my traditional three-tiered architecture where I have my, say, my database servers, my web servers, my application services, generally these will be put into 3 different VLANs, VLAN 100, 200, and 300. This is what the network architecture will offer you. And we'll try to create access lists in between these. So these little icons between the rectangles are, let's say, switches. And if it's a traditional data center environment, we'll create access lists there. If it's a cloud environment, these may be security groups in a VPC. But the reality is that modern workloads do not stay put in VLANs. This may have been the case 20 years ago, but in a VMware environment, VMs vMotion. In a Kubernetes environment, pods die and come back with new IP addresses. They may be on a different segment. So the fact that the workloads are dynamic and move around means that we can't rely on the traditional network three-tiered architecture to do this. If we use metadata, we can actually free up the network to do what the network was designed to do. So Illumio has this idea of a four-dimensional metadata or labeling system where we can take every workload and view it from four perspectives. We can tell every workload that you have a particular role, you're either development or production, you are a particular application like SQL, you are located in a particular environment, data center or cloud, and you're located in a location. You're located in London or in Stockholm or in Tokyo. We can now use that information to start identifying them from a security perspective. So we can grab all of our SQL servers and write policy based on that, freeing up the left side of this diagram. So if this is a traditional data center, we have now freed up those switches to do what they were designed to do. Because if we write too many ACLs, we can run the risk of say, filling up TCAM. We can reach similar scaling limits in a cloud environment. So we want to free up the network to do what the network was designed to do, and do this type of workload-specific policy differently, using some human-readable metadata without worrying about IPs and ports. Now, this is so Illumio uses an agent-based solution, and it's important to keep in mind that there are two ways of putting an agent on an OS. You can put it in the user space, or you can put it in the kernel space. If you put the solution down in the kernel, this is generally if you are a virtual firewall, or if you are going to inspect packets and redirect them. And this involves modifying the kernel. Or you can put the solution in the user space and have it simply sit there and manage what's down at the kernel. This is important when it comes to failure scenarios, because often whenever you put any kind of third-party agent onto any OS, the question comes up, what happens if you crash? What happens if your solution dies? Are you going to break what's going on in my environment? Do you fail open, meaning that if you crash, everything goes through and there's no inspection? Or do you fail closed, which means that when you die, everything stops until you come back to life again? Illumio's answer is really a third one, and that's no, we don't do either of those things. We so-called fail safe, because we're sitting in the background, we're collecting telemetry, we are configuring IP tables in the case of Linux. If we crash, IP table still works. Traffic is still being enforced based on the last rules that were implemented. And while in the background, we are spinning back up to life, production continues using the exact security policies that have been implemented. They don't die, they don't get deleted. So in a failure scenario, even if you have 10 workloads or 100,000 workloads, if this solution completely dies, production is not impacted at all. Security is not impacted at all. Everything remains exactly the way it was while we spin back up to life. So this is important to keep in mind. You want a solution that doesn't fail closed or fail open. You want it to fail safe, okay? So we want to be able to segment every single one of these workloads in such a way that we protect ransomware. We want to block ransomware without doing anything else. We're not ready to go into full enforcement mode. That goal is the ideal. I want to have a zero trust model where everything is enforced. Everything is blocked except what I want, but I'm not quite sure what I want. But I do know today that I don't want ransomware. So you can do this directly at the GUI. Illumio also has a scripted approach to this called the containment switch, where you can have this ready to go in a workloader environment, and you can immediately hit the switch or execute the script, and this can immediately be implemented within seconds across your entire workload, almost as a sort of an emergency approach. What we want to do is sort of build a wall around every single one of our workloads, and somehow have each one of these walls block ransomware at scale. And we want to be able to do this again with a PCE, which is the engine that Illumio uses to define all this policy. And we can do it there directly, or we can do it with the workloader scripts in the upper left here. The solution involves putting the agent on every single workload and then issuing some API calls to the engine. And this immediately blocks the relevant ports on these workloads, blocking only RDP or SMB, but allowing everything else. Okay, and this should be the case whether it's bare metal VMs or containers. Only RDP is blocked between all these workloads, because workloads should not really be speaking RDP to other workloads, but all other ports are allowed. Then this, again, should be regardless of scale. So you want to be able to, within a couple of clicks, block ransomware instantly across your entire fabric, across every single cloud, across the entire world, if it's that big. And we want to be able to do this with workloads identified either through their FQDNs or their IP blocks, or their metadata that we've applied to it. So we want to be able to say maybe all my dev servers should have RDP blocked to all my web servers, or dev to prod. I may have a few exceptions out there. Maybe just certain jump hosts will need to speak RDP into these environments, but I don't want them speaking to each other, because this is how ransomware propagates. So this allows me to very quickly block these ports. And this is an example. So this is an example of how Illumio views workloads. So these are 4 workloads: 2 purple ones, which are databases, and 2 blue ones, which are web. And we see some lines going between them showing the traffic is flowing. And there's no realistic scenario here where RDP is needed to speak from the database to the web. There might be RDP needed from a jump host into it, but these should not be listening to RDP to each other. There's just no realistic scenario. So we want to be able to take these workloads. Again, these are 4, but these could be 44,000 workloads. I want to be able to very quickly do this. And there's a tool that Illumio has called an enforcement boundary. And instead of going to every single workload and trying to granularly define who can talk to who, we just want to sort of across the board block everything with a wall, or with a boundary. And in this case, this boundary will block RDP everywhere. So I want to say all workloads of one type cannot speak RDP to workloads of another type. And this is sort of like reversing the firewall workflow. Traditional firewalls don't work this way. This is do my deny all rule first. Usually in a firewall that comes last. But here we're sort of putting it first. We're doing the deny all and then allowing the exceptions through, as opposed to a firewall where you define first all of your allow rules and then you have a deny rule at the end. And in the firewall case, rule order matters. I have to be very careful how I put my rules, which rule goes before or after other rules. This enforcement boundary on the left means you don't need to do that. You create this blanket wall across all your workloads, and then define the exceptions afterwards, such as those jump hosts that might need RDP. And then we go back and we put our workloads into what's called selective enforcement, as opposed to full enforcement. We are selectively enforcing. And these little dotted lines mean that all these workloads are free to speak to everybody as normal, with the exception of what we just did. We just blocked RDP. RDP should never be spoken between these workloads. We can now go and create a couple of exceptions. So the jump host that my support team has, they can talk into it. But I have created this protection, this protected wall around all my workloads. Again, remember, at scale, these are 4 workloads, but you can have 40,000 workloads, 140,000 workloads, and within a couple of clicks, either through the GUI or scripted, I have immediately blocked ransomware everywhere across my entire environment. And I've blocked 70% of the problem out there. So the containment goal is this, that once I have this, the first workload that gets infected with ransomware becomes my last workload infected with ransomware. There's just no way for it to propagate. I have very carefully quarantined the problem. And I can now continue with production as normal. I still want to go towards that full enforcement goal. And once I do that, I don't really need this. I can turn this off, because in my full enforcement mode, I'm going to be blocking RDP anyway. But this allows me to solve the problem today without having to reach that eventual goal. So the benefits of Illumio's approach to ransomware are a few, is that this allows us to maintain full visibility of traffic everywhere, so we can see what's going on from an application perspective. Again, we don't want to have to ask the network to show me what these resources are doing to these resources and give me a bunch of networking information. I don't want to have to pay attention to VXLANs and to VLANs and to subnets and to peering points. I just want to know who's doing what to who from a high level, okay? And I want to be able to very quickly reduce the risk without having to understand all of the underlying networking fabrics. I want to be able to protect all of my workloads or a segment of my workloads from ransomware quickly. I want to be able to block other ports. So in this example, ransomware using RDP, SMB is another common one. There might be other ports I want to block. I just want to very quickly be able to deny particular traffic while allowing everything else, until I get to that goal where I do the reverse, where I'm only allowing everything that I want and denying everything else. And I want to be able to contain this quickly. So containment is a word that we use often. We want to have this script lying at the side. We can have this as a workloader script, and we can just execute it instantly for a fully automated, orchestrated approach, or do this visually through the GUI. This is a declarative model. So think of this almost like you might say, hey, Alexa, play some music. This is like, hey, Illumio, block ransomware. I'm defining what I want, and the tool should be able to figure out how to do it. So, and I don't want to worry about rule order, because in a traditional firewall, if you do this, you have to be very, very careful how you do your orders. So you have to know the how. You should really only need to know the what and have the tool to find the how. Again, this wall is a blanket across all workloads, and then these are overridden by specific allow policies. So again, these are, we might need RDP in some cases. So we create the wall first, and then we create the exceptions afterwards. These rules are unidirectional, so I can allow traffic in one way and block in the other. And again, this is specifying what cannot happen. So as we are defining what is to be blocked, not what is to be allowed. And again, we should not be limited by identifying workloads using networking constructs, because in my data center, I might have an SDN solution and it's identified one way there. If I move it out to a public cloud environment, segments are going to be referred to in a different way. I don't want to have to know what those are in order to implement this policy, because I may, again, want to move my workload between them without having to reinvent the wheel. This is often a problem in brownfield environments. If you are lucky enough to have a greenfield environment where you're building something from scratch, this is easier to implement using perhaps your existing tools. But most people have an environment of some kind, and they want to block ransomware today in that environment without having to go into a new environment. And again, this is meant to be sort of a temporary solution. We all want to get to that full enforcement mode, that full allow list model where all of my workloads are segmented and everything is blocked except what I want. But that requires that you understand your environment, and many people are not yet there. So this allows me to solve that ransomware problem right now this morning without being the next item in the news about being held hostage from some hackers who have discovered this 30-year-old tool called ransomware. So thank you very much. We do have some time for questions, and hopefully this makes a bit of sense. This is a way of protecting you today from a problem which will allow you to sleep at night and not be the next problem that's being talked about in the industry.
Welcome back. Thank you for the presentation, Christer.
Sure.
Let me check if we have some questions. Yes, we have a few questions for you. The first one is, what's the best approach to segmentation in an environment with legacy devices, such as mainframes where no agent can be installed?
Right. So most people will have some kind of mixed environment, right? You're not going to all have Linux, all have Windows. There's two approaches to that. One is devices from which no agent can be installed are generally sitting behind a switch or a router of some kind, and there's going to be access lists going in and out of that environment. With Illumio, you can consume information from these switches. So you could go turn NetFlow on, for example, and we can collect information about traffic that's going in and out, and so we can know exactly what's out there. And then you can write rules in Illumio, which will get translated into access lists, which can then be pushed down to that Cisco switch or to that Arista switch. So we can actually enforce network layer switch enforcement as close to that device as possible. The other approach is using the enforcement boundaries. If you have, say, a mainframe, or if you're in an industrial environment and you have some kind of controller in the center on which no agent can be applied, all the devices in that environment would be managed by Illumio, and you could define an enforcement boundary. So as I mentioned, an enforcement boundary is sort of starting with a deny all. So you can start with a rule that says nobody to this mainframe, except, and then create a couple of exceptions. The following hosts are allowed to speak to that, but by default, nobody else is. So we can either do it that way by sort of reversing the firewall way of thinking, or actually configure the switches, and probably a combination of both. So this comes down to the question of, do you need an agent to do all of this? And the answer is no. We also now have the ability, for example, in a cloud environment. In cloud, you often have things that you cannot put agents on, but we now have the ability to consume information from the logs. So anything that's in cloud creates a log. We can consume information that way and enforce security as close to that device as possible. So we want to be able to do this with or without an agent.
Good to know. Other question from the chat. If I have already segmented my environment around network boundaries, will adding micro-segmentation to the picture make troubleshooting more difficult?
So often you will probably have already created some segmentation to begin with. So you have your VLANs, you have your subnets, you know, and now we're talking about doing it again. It actually will make troubleshooting easier because in a traditional environment, if something breaks, the first person you blame is the network people. Somebody broke a firewall, somebody broke a network, and they say no, and they push back, and you have sort of this fight back and forth for who, you know, who needs to do troubleshooting. This allows you to start at the source of traffic. So packets are born at a workload. This Illumio allows you to absolutely verify whether or not that has happened, whether there's a problem there. So at the workload, the packet is either blocked or allowed. And now if that has happened, if that is successful and the packet has entered the network and now there's a problem, you can very clearly explain to the other operations teams what has happened, because usually we're operating blind. Often in troubleshooting scenarios, nobody knows what's wrong. Everybody's just, you know, pointing fingers at somebody else. So this allows you to do the enforcement and the visibility without having to deal with a network team. Now, I say this as a former networking person, because often these are sort of political boundaries. Nobody wants to be blamed for this. So this allows you, the systems, the DevOps, the person running the system, to have full control over visibility. You do your own troubleshooting first. You verify it, whether it does or does not work, before you pick up the phone and talk to the other team. So it actually is a much more clear division of troubleshooting rather than this usual argument that goes back and forth. So in my experience, this actually speeds up troubleshooting. It does not slow it down.
Okay, good. So other question from the chat. Does Illumio add endpoints to its visibility and enforcement, such as laptop?
Yes. So if you look at our examples, what we're showing is workloads in the data center and workloads in a cloud. But there are people who are accessing this endpoints, right? Laptops, remote systems. So you can also put our agent there. And now when you look at our GUI, our platform, you will see a combination of all of them. So the idea is that we want to have full visibility end to end, every possible place that your workload can reside, all the way from a laptop to a data center to a cloud to containers to serverless. We want zero blind spots. So the answer is yes, you can put the agent on the laptop. And this is where scale becomes important, because if you do that in a relatively large environment, now you potentially have a very large number of things to pay attention to. So instead of a few hundred or a few thousand, you might have 10 or 20,000 things to keep track of. And you don't want to have a tool that's going to sort of stop when you get to the number 1,000. So if you have all of these laptops and all these contractors and who knows who connecting into it, you want to be able to see everything. So we have the ability to view everything all the way from the laptop, all the way into the most hidden serverless environment in cloud. So the answer is yes. They're deployed a little bit differently, but at the end, when you look at our window, our platform, it's one view for everything.
Well, thank you for the answer. It seems there is no other question so far. Don't be shy. No question is coming. So thank you once again for your time. Thanks to everybody to attend this presentation. Please stay with us all day. There is other presentation is coming, and thank you very much. Bye.
Okay. Bye.